So you need to start by looking at all the patterns that you can notice. Don't worry about if what I showed you now is different than how I showed you in your notes. There's more than one way of doing things. Here, you should start to notice there's a 1 everywhere. One section of it goes 1, 2, 3, 4, 5, and then look to see the other things you notice for pattern. What you can do is you add the 2 numbers above it to get that number. So 4 plus 6 is 10, and 4 plus 1 is 5, and 5 plus 10 is 15, and there are other patterns in this Pascal's triangle, and one of these days I will show them to you. But here I just wanted to point out that you might know something important about the numbers 1, 3, 6, 10, 15. We'll come back to Pascal's triangle later. Right now we're just going to multiply this binomial x plus y. So here I have x plus y times x plus y squared. That's going to give us x plus y cubed. You get that by taking x times each one of those numbers in the trinomial, and then you take y times each one of those numbers in the trinomial, and then you combine like terms. Here we're going to do x plus y to the 4th power. So we're going to take x plus y times x plus y to the 3rd power. So we're multiplying. Be sure to use the distributive property. So we have x times x to the 3rd, and then we have x times 3x squared y, then 3xy squared times x, and then x times y cubed. And then you take y times each one of those. Multiplying all that can be a lot of work. So we look for the patterns between the original and the answer and see what sort of shortcuts we can come up with. So look at x plus y to the 3rd power, and when you look at just the coefficients, notice they're 1, 3, 3, 1, and then you look at Pascal's triangle and there's a row that's 1, 3, 3, 1. Then you look at the expansion and you see that to the power 4 is 1, 4, 6, 4, 1, and you look at Pascal's triangle and there's a row that's 1, 4, 6, 4, 1, and you can do that with each row. We could just keep multiplying by x plus y each time, and that gets to be very tedious, and so we look for the patterns so we can do the shortcut each time. The x exponents here are 5, then 4, and then 3, and then 2, and then 1, and 0. And then here it's 4, 3, 2, 1, 0. Then the next one's 3, 2, 1, 0. The y's go in reverse. They're 0, 1, 2, 3, 4, and 5. It also works for the higher exponents. Here it's x to the power of 8, and then 7, then 6, then 5, and so on. So when you do a problem, it's to the power of 5. So you take the 5th row of Pascal's triangle, and then you do x to the power of 5, and then 4, 3, 2, 1, 0. And then you do y in reverse. And anything to the power of 0 is 1. And then you go through and you multiply everything in a column. So that's 1 times x to the 5th times 1. And then 5 times x to the 4th times y. Then 10 times x cubed times y squared. And you keep going that way. So we do the same thing, but these are a little more complicated, so it helps to have it more spread out. It's to the power of 4, so we use the 4th row of Pascal's triangle. Then we have 2a, and that's to the power of 4, then 3, then 2, and so on. We do the same thing in reverse with b. And 2 to the 4th power is 16, 2 cubed is 8, 2 squared is 4, 2 to the 1st is 2, and anything to the power of 0 is 1. And when they're in parentheses like that, it's 2 to the 4th power and a to the 4th power. The stuff in red is just the work, so when I multiply that first column, it's 1 times 16a to the 4th times 1, and then 4 times 8a cubed times b. And then I just use the black and the brown for my answer. This one's also a little more complicated because of the b to the third power, but the whole thing is to the power of 5, so I use the fifth row of Pascal's triangle, and then it's a to the power of 5, then 4, then 3, and so on. And you use b cubed every time, and those go in reverse, so they're to the power of 0, then 1, then 2, all the way up to 5. Anything to the power of 0 is 1, and anything to the power of 1 is itself. When you have a power raised to a power, you multiply the exponents, and that's how you get b to the 6th, b to the 9th, b to the 12th, and b to the 15th. Then you multiply each column, so you have 1 times a to the 5th times 1. Then you have 5 times a to the 4th times b to the 3rd. There's a small difference when there's a negative sign. So what you do is you put a negative y for each term. So it's going to be negative y to the power of 0, then 1, then 2, then 3, then 4. And just think about a negative number times a negative number is going to be positive. But if you have 3 negatives, it's going to be negative. So what happens is every time there's an odd number of negatives, it's negative. But when there's an even number of negatives, it's positive. So when the exponent is odd, it's negative. And when the exponent is even, it's positive. Here's one of the more complicated ones, just as an example, so you can see and compare. But I want to make sure to tell you, all that stuff in the middle is you showing your work. So it shows me that you actually did it and didn't just cheat and use a computer. Let me know if you have any questions.